Good evening, dear students. In last class, we discussed the entropy and the factors of the Carnot cycle. Entropy, that is the factors of entropy here. One is the temperature and volume, another is the temperature, pressure, and also the physical significance of entropy. Okay, in today's class, I am going to discuss about the efficiency of heat engine. Unit is thermodynamics. Efficiency of heat engine. Efficiency of heat engine. Here the efficiency of heat engine. Here you know the W is equals to Q. W is equals to Q. Q is the heat and W is the work. Here the net work done here W is equals to Q. That is the relation between W and Q. That is the net work done at the and when heat absorbed or after you know the end of the cycle, that W is equals to Q, that is the net heat absorbed or evolved, and can be this put in the two equations, that is as discussed already the before, that is in case of adiabatic expansion and ideal gas. Adiabatic expansion and ideal gas, that is Cv is equals to log of T2 by T1. Cv is equals to log of Cv into log of T2 by T1. Therefore, this is equals to R, that is R log of V2 by V1. R log of V2 by V1. This is the second for the step. Yes, for in step 2. Next, there is another equation. One is adiabatic and another is adiabatic expansion and of, that is ideal gas equation. And here Cv log of T2 by T1. Therefore, this is equals to log of T2 by T1. This is the second. Next, another, that is Cv into log of T2 by T1 is equals to log of V4 by V1 or log of V4 by V1. This is fourth case. Log of V4 by V1. From these equations, we are complete this equation, we get that is V3 by V1 V3 by V2 is equals to V4 by V1. And then to write the V2 is taken V2 in this side. V2 divided by V1 is equals to this V3 and divided by V4. V3 divided by V4. This is V2 by V1 and here V4 by V1. Taken here V3 by V2. Consider here for the above equation V3 by V2 is equals to V4 by V1, and next you write from this V2 by V1 and this V3 by V4. You write that is a V3 by V4, V2 by V1. Okay, next in this equation, that is from equation number 5. We get the W is equals to the RT2 log of V2 by V1 minus RT1 log of V3 by V4. From according to equation, that equation number 5, that is W is equals to RT2 R T2 log of V2 by V1, V2 by V1 minus R T1 log of, sorry, R T1 log of V3 by V2, or T1 log of V3 divided by V4 with written, that is the V2 by V1 is equals to V3 by V4, and you substitute that value in this equation. That is, here the W is equals to, according to equation number 5, here W is equals to RT2 log of V2 by V1 minus RT1 log of V3 by V4. You written V3 by V4 is a V2 by V1. Then you write that is W is equals to RT2, W is equals to RT2 log of V2 by V1, RT2 log V2 by V1. Therefore, this here minus RT1 log of V3 by V1, to substitute in place of RT1 log of V2 by V1. Here, you take this is RT2 log V2 by V1, RT1 log V2 by V1. That is log V2 by V1. You take up R log of V2 by V1, and this is a T2 minus T1. The remaining is a T2 minus T1. Therefore, W is equals to, you take outside R log of V2 by V1 into T2 minus T1. T2 minus T1. Here you taken outside log of V2 by V1, and remaining is a T2, and here T1, remaining only T2 minus T1. Then that is a, you write this is equation number E, or continuous equation number 7. This is the equation number E. Okay, then I write another equation. Therefore, from equation number 6, write here, this is the W. You find it next, that is, you know, the W, the efficiency of heat engine is W is equals to Q. Here W is equals to R log V2 by V1, V2 minus V1. This is equivalent to this Q. Next, you consider Q. Q is equals to R T2 log of V2 by V1 minus R T1 log of V3 by V4. You know, Q is equals to R T2 log of V2 by V1 minus R T1 log of V3 by V4. Here, you know, the V3 by V4 is a V2 by V1. Here, you substitute RT2 log of V2 by V1 minus RT1 log of V2 by V3 by V1 is a V2 by V1. This one, therefore RT2 log of V2 divided by V1, this is 1 minus RT1 log of V2 by V1. Therefore, this is equals to R log of V2 by V1 is taken outside, and remaining T2 minus T1. This is equation number. You compare the equation number 1 and that is equation number 7. And here you get a W is equals to Q. Here the W is equals to Q, that is, see here, this is a Q. W is R log V2 by V1. Here Q also R log V2 by V1. Here also T2 minus T1, and here also T2 minus T1. And that is a W is equals to Q. And here we know that is a QAB is a RT2, QAB is a RT2 log of V2 by V1. Here you know that QAB is equals to RT2 log of V2 by V1. Comparing the equation 7 and 7. And finally you get that is a W is equals to QAB. W is equals to QAB. QAB, that is T2 minus T1 divided by T2. T2 minus T1 divided by this one T2. Here you get this equation. According to the work done, the efficiency of heat engine. This is here the replacement of, that is W is equals to QAB T2 minus T1 divided by T2. As general term, this Q is the general term, Q is the, it is written as T2 minus T1 divided by T2 is less than 1. This is a T2 minus T1 divided by T2. This is a less than 1. Here this is less than 1, and then it follows that is a W is greater than Q. Therefore, here W is greater than Q. In the other words, only part of that they absorbed by the system. Here at a temperature, here part of the system is absorbed by a temperature. T2 is converted into, that is a useful work. Here the temperature T2 is converted into a useful work. That test of this, that is given out by the system to the surrounding here. The heat is giving here, it is greater than Q, and here it is out, it is a giving system to the surrounding when it is at a lower temperature, that is a T1. Here the T1 is giving the system to the surrounding, and this T2 is using for the work, that is W is greater than the Q. And thus the total heat absorbed by a system cannot be completely converted into work. Here, therefore, I write the confirmation. Here. A conclusion here. Therefore, the total heat absorbed by a system, the total heat absorbed by a system, absorbed by a system cannot be completely, here the total heat is absorbed by a system cannot be completely converted into a work. Here T2 minus T1 divided by T2. Here the T1 is using, or T2 is using for work, and T1 is transferred from the system to the surrounding. Here the total heat absorbed by system cannot be completely converted into work. And this completely not converted into the work. W is equals to Q, not a Q is equals. That is a W is greater than Q is. This is the efficiency of heat engine. Okay, next, the criteria for the spontaneity. This is also important for 2 marks. This is 2 marks important. Criteria for the spontaneity. Criteria for the spontaneity. Criteria for the spontaneity. Criteria for the spontaneity. This is a very important for 2 marks question. Here, the criteria for the spontaneity is this is the efficiency of the heat engine. This is the criteria for the spontaneity is the efficiency of the heat engine. That is the criteria for spontaneity is denoted here. It is the eta therefore is equals to W. So here W by Q is denoted as that is equals to W by Q. That is the efficiency of a heat engine and the ratio of the work obtained in a cycle. That is the ratio of the work obtained in a cycle is this is denoted as W. This is a ratio cycle. Here the ratio here the ratio of the work obtained in a cycle. The ratio of the W means work obtained in a cycle. Ratio of work obtained in a cycle, that is W. This is a W. And to the heat taken from the higher temperature. And this is a to the heat taken from the higher temperature. Taken from the higher temperature. Here the W is the ratio of the work obtained in a cycle and Q is the heat taken from the higher temperature. That is this is a Q. Here that is a W and this is a Q. It is known as capital Q and here this is referred as a efficiency, that is referred as the efficiency of a heat engine. This is known as a efficiency of it is referred as efficiency of heat engine. See here, the heat engine means that is to the ratio of work obtained in a cycle, that is work obtained in a per cycle, then to the heat taken from the higher temperature, that is referred as the efficiency of the heat engine and the formula is written as is equals to W by Q. Here Q is the heat taken from the higher temperature, here W is the work obtained in a cycle. And here heat engine can convert all the heat from the high temperature reservoir. Here it convert the all the heat. In this all the heat it convert all the heat into work. All the heat into or it convert all the heat from the higher temperature, that is higher temperature means to the higher temperature, and the heat convert into here it convert all the heat into a higher temperature reservoir into work. Higher temperature reservoir into work. Higher temperature reservoir into work and such engine will be 100% efficient. These engines are these and therefore such engines are the 100% efficient. the efficiency of the heat engine, and in that the criteria for the spontaneity, and one criteria for the spontaneity means the all it convert all the heat from the higher temperature to the into the work. The higher temperature, it all will convert into a higher temperature reservoir into a work, and this is such engine. This like engines prefer or these engines are the and it is a 100% efficient. This is the criteria for the spontaneity. Okay, next gives free energy and work function. Gives free energy. This is also important. Gives free energy. Gives free energy and work function. Gives free energy and work function. Here the free energy can be defined as, you know, the formula G is equals to here. This is a gives free energy, and that is this gives free energy is a G into H minus Th. H minus Ts. Okay, here where H is a heat or enthalpy here. This H is a heat or enthalpy of the system, and T is a its absolute temperature, and S is a entropy. Here H is a enthalpy, a heat, that is H is a heat of enthalpy of the system, and T is the its absolute temperature, and S is the its entropy. S is a entropy and G is a gives energy. It is denoted as G. And here let us consider in this equation it is considered system which undergo change of system from a state 1 to 2. Here it is the change in system. Change in system means change of system, that is 1 to 2 at a constant temperature. Then we have this equation here, the change in system, that is a considered system which undergoes change of system. Change of system means you write here this is a change of system. Change means you write delta G is equals to delta H 1 to 2. Only 1 to 2 means this one, and here this one. Here 1 to 2 system. Change of system from state 1 to state 2. Here that is delta H minus delta T, yes. Okay, delta Z is equals to delta H minus delta T. Let's see, consider this is the equation number 1. Okay, D delta G is a G1, that is G2 minus G1. You know G2 minus G1. Delta H means that is a H2 minus S1, H1. H H2 minus H1, H2 minus H1 minus delta T means that is a, so here you write this is a delta T into, so I written this is a T into delta S. T into delta S. This is a its absolute temperature. Here you write T into S means S2 minus S. Okay, here change in gives energy, here enthalpy, and here entropy. Entropy here it gives free energy G2 minus G1, therefore this is equals to H2 minus H1 minus T into S2 minus H1. So S1, and here you write, you know the equation, you know that this one changing enthalpy, that is delta H is equals to delta E plus, we know that delta H is equals to delta E plus P into delta V. Pressure change in volume, and here change in delta H equals to delta E plus P into delta V. Next you write delta G is equals to delta E here. This is a delta G. You substitute this value in this, and here P delta V minus P delta S. Here delta T delta G is equals to delta H means you know delta E plus P delta V. Here delta E plus P delta V minus T delta S. And here according to the work function gives the energy work function according to work function according to work function according to work function, that this is A is equals to E minus Ts. E minus Ts according to the work function, that is A is equals to E minus Ts. You write the change in here delta A, change in state work function, that is delta A is equals to delta E minus here Ts means that is a T into delta S, that is this S is the entropy. You write T into delta S. And this is the equation number. This is delta G equals to delta H minus T into delta S. You written this is a change in G2 minus G1 is equals to S2 minus S1 minus T into S2 minus S2. Where this delta H is the delta E plus P into delta V. Here you substitute this value in this equation 1, and here delta G is equals to delta E in place of delta H, delta E plus P delta V minus T into delta S. Okay, afterwards according to work function, that is A is equals to E minus Ts, that is delta A is equals to delta E minus T into delta S, equation number 2. By comparing this equation, we get that is here this equation and this equation. We are comparing these two equations, and finally we get that is delta G is equals to delta A plus P delta V. Here that is delta G is equals to delta A, and you get delta G is equals to this one delta A plus P delta. Okay, here you get P delta V. This is a delta. That is delta G is equals to delta A plus P into delta. Comparing the equation, this one and this one, you get delta is equals to delta A plus B into delta V. Here the presence of delta S, T delta S here cancel, and delta E. Finally, remaining are delta G is equals to delta A plus P into delta V. And this is a equation number 2. Okay, this is a equation number 3. And again we have the delta S can be defined as Q by T. that is delta S is a Q by T. Q is the heat taken off your here. Q by T here where Q is the heat taken or your heat taken or that is heat is a taken or your delta Z is equal to delta A plus B delta B and then now the delta S can be defined as that is a Q by T where Q is the heat taken or evolved and afterwards there is a delta S is equal to Q by T. Therefore, delta S is equal to Q by T. This is a change in entropy. Here, delta S is equal to Q by T. Or you write the Q reversible divided by temperature. Or delta S or this write Q reversible divided by temperature. Where here Q reversible heat taken in the system. Here this Q is the heat taken in the system. Heat taken in the system. This Q is the heat taken in the system. And afterwards, therefore the work function delta A can be given as therefore the work function that one the work function therefore the work function is given as that is delta A is equals to delta E that is T into delta S means this one Q reversible here that is delta A is equals to delta E this one delta A is equals to delta E this change in entropy that is Q by T only change in entropy Q by T means delta is substitute delta here in this delta T into Q reversible divided by T. Here this T and this T is next the remaining is delta A is equals to delta E minus Q reversible. Delta A is equals to delta E minus Q reversible. Q reversible. Next, this is the equation number 4. This is equation number 3 and this is the equation number 4. According to first law of thermodynamics, delta E is Q reversible minus W. According to first law of thermodynamics. According to first law of thermodynamics, therefore that is dE is equals to this is according to first law of thermodynamics dE is equals to the Q minus W. Q reversible minus W reversible. And here you substitute this equation in the equation number 4. That is where you write the delta E here minus W is equals to you take in this side minus W is equals to dE minus Q reversible minus W reversible is equals to dE. Therefore, here write minus W reversible is equals to dE minus Q reversible. Here this is delta A is equals to delta E minus Q reversible. Afterwards, according to first law of thermodynamics, take delta D is equals to Q reversible minus W reversible. You take outside minus W reversible is equals to dE minus this Q reversible put in equation number 4. And here you put the equation number 4, and here therefore you get the, it changes the equation number 4, that the equation number 4 is changed. Okay, see here the minus reversible, or you take this is a Q reversible is equals to the dE plus W reversible. Here Q reversible is equals to dE plus reversible, and therefore delta A, this equation let delta A is equals to the, that is dE Q reversible minus W reversible. Q reversible minus W reversible minus, that is Q reversible. Q reversible. Finally, you get W reversible minus Q reversible. Here this minus, and here you get the positive value. Here finally you get, that is delta A is equals to positive W reversible. You get this is the delta A is equals to positive W reversible. Here this is a positive value, and here this is a negative value. Minus Q reversible is equals to dE minus Q reversible. W reversible is equal to dE minus Q reversible. Afterwards, here this, that is the decrease in the work function. Here this is a decrease in the work function, that is decrease in the work function, decrease in the work function, that is minus, you write minus delta, you write here you are taking this one is a minus delta A is equals to W R reversible. Here you adding this value minus Q, and you take this is a minus W, or you take here minus delta A is equals to positive W reversible. This is a minus delta A reversible, and this is a equation number 6. This is equation number 6. You know the equation number 5 is, that is equation number 5 is the minus W reversible, that you, this gives the equation number 5. You write directly give the equation number 5. And here this is a minus reversible, dE minus Q reversible. This is equation number 5, and this here minus delta A here. Minus delta A is equal to this minus W, and afterward you take this side, and here the minus delta A is equal to plus W reversible. This is equation number 6. Here this is equation number 6 is any process at constant temperature. Here this equation number 6 is any process at a constant temperature. Any process at constant temperature gives the maximum work obtained from the system. Here at any process, here according to this equation number 6, at any process at constant temperature gives the maximum work, gives the maximum work gives the maximum work obtained from the system. Gives the maximum work obtained from the system. Maximum work obtained from the system. This is a gives free energy and work function. And this equation is known as the gives free energy and work function, that is delta A is equals to positive W. This is a state of work function. Okay, I'll stop here only. May I discuss in next class, that is the variation of free energy. This one, the variation of free energy with temperature and pressure. Variation of free energy with temperature and pressure.